this training program, which is our first national training program. And the idea here is to provide basic concepts of a particular on a particular theme, and also the insight to some practical issues to our young researchers and students and extension workers. In this context, sir, we are highly delighted that we have received an overwhelming response to this idea, and we are happy to inform you that over 200 participants have registered for this training program. Most of these participants, they are representing various corners of our country, and basically we are having representation from all north, south, east, west. So we are highly thankful to these participants who have shown such interest, and I welcome all the participants who have shown their faith in our initiatives and have been very kind to support our activities. Most of these participants have been regularly attending our any activities like conferences, etc. They have been regularly attending. With this, I also request all the participants that please provide a frank feedback about this training program at the end, so that we can try to improve upon by your guidance for our future activities. I also welcome all the learned resource persons who have accepted our invitation to deliver lectures during the training program and to share their valuable experiences with the participants who will be attending this training. I also welcome our chief patron, members of the Academy, EC members of the Academy who have always supported to organize such events. Last but not least, I welcome and congratulate the organizing team, especially Dr. Sanjay Arora, Dr. Pradeep Kumar Rai, Dr. Vivek Amaria, who have conceptualized this training program and have made all efforts to make this program a successful event. Once again, I welcome all of you and thank you very much.
Thank you, Dr. A.K. Singh, for giving a formal welcome to the chief guest as well as participants. Just I will be brief for the sake of the information that I want to introduce the academy, the activities. Already some brief have been outlined by Dr. A.K. Singh. The academy was initiated in 2019 at Lucknow by a group of professionals, including scientists, researchers, academicians, students, as well as farmers. And we are working for the knowledge sharing, especially imparting training, organizing conferences, and interacting with the scientific fraternity in the field of natural resource management and conservation throughout the globe. The academy, please mute yourself to avoid any disturbance during the program. The Academy is a non-profit organization and devoted for the cause of conservation and management of resources, especially soil, water, forest, and overall environment. I have to means sometime due to disturbances we have to mute. Prashant, please mute yourself. Okay, with the blessings and support of Dr. G.B. Singh, ex-DDG, NRM, and former Vice Chancellor, JNKVB, Jabalpur. He is the chief patron of our academy. Dr. D.K. Sharma, former director, CSSRI Karnal, who is patron. Dr. Y.P. Singh, Senior Vice President, who was former head CSSRI Regional Station Lucknow. Dr. T.K. Srivastava as Vice President of the NRCM. They all are means guiding us and supporting us, and blessings are blessing us in terms of any help and support and guidance. We have more than 45 life members, and we are representing more than 16 states of India. We have organized several events, including important days like World Soil Day, World Environment Day, Population Day, and Water Day. Apart from organizing conferences on different themes and aspects, the Academy is also publishing a e-journal, Journal of Natural Resource Conservation and Management. Dr. A.K. Bhardwaj is the chief editor, and the journal is available on website, and our website is being updated timely. And we are also planning for a publication of newsletter, and several books and outcome of the conference proceedings have been published during last 3 years. And recently we have got the certificate from the income tax means exemption also. So we are moving towards a good professional association or organization for the benefit of the academician and professionals. I, on behalf of ANRCM, welcome you all to this event, and we intend this is a 3-day program, and the participants should have a very good interaction, knowledge sharing, and this will be beneficial for all of us. With this, I thank you for joining. Now I introduce our chief guest, Dr. Ashok Kumar Patra. He is a renowned soil scientist. Globally, he is renowned. He is one of the 13 soil scientists of the world advancing soil research and education as per the Food Tank USA in 2017. He did his graduation and post-graduation from BHU and IRI New Delhi, and he is presently Director of Indian Institute of Soil Science, Bhopal. Earlier, he served as scientist at IGFRI Jhansi, as well as CIFE in Mumbai, a senior scientist and principal scientist at IRI New Delhi, and he has vast experience at ICRISAT as well as Institute of Grassland Environmental Research, UK, University of Notre Dame, USA, and postdoctoral fellowship at ICRISAT as well as INRA postdoctoral fellow in France 2001 to 3. He has been honored with several awards, especially elected as the Karuna Nidan. Please mute yourself. He has received several awards, especially Fellow of National Academy of Agriculture Sciences and Sardar Patel Outstanding ICR Institution Award during his tenure as the director of the institute. And King Bhumi Bol World Soil Day Award in 2020. Under his leadership, it was received. So he has he is a dynamic soil scientist, and he headed the Indian Society of Soil Science dynamically, and we are fortunate that he is with us and I want to brief about the soil health issues. Actually, Dr. Patra is a renowned soil scientist in terms of he has delivered and worked especially on soil health management. So we have requested him to be the to inaugurate this program. So I request Dr. Patra to kindly give his inaugural address for today's inaugural session of the Academy's training program. Thank you, sir. Welcome, sir, Dr. Patra.
Thank you very much, Dr. Arora Saab. Am I audible? Is it okay?
Yes, sir. Yes, sir. Very good.
Thank you. Thank you very much. I'm really thankful and grateful to you, the President, and all of the Academy of Natural Resource Conservation and Management. Thank you for inviting me and to be in this inaugural program. Subject, is close to my heart. We all working in this direction only. So, Dr. Atul Kumar Singh ji, President of the Academy, you, Dr. Sanjay Arora ji, and Dr. Pradeep Kumar Rai, who is the course director, and all the patrons and associated in the academy, and all the participants, the resource persons from different institutes of ICR and agricultural universities. I see my colleagues also, Dr. A.B. Singh from this institute, who has joined. Also, I see my students also online who will be delivering the lectures. This is a, I must congratulate you, Dr. Arora, that you have mobilized a good number of good people from different parts of the country, and also your society is working in a very, very young society, but doing very well in a very short time. And you are also, you see the academy 3 days this program, 25th to 27th. So, and I understand that you got all formalities, the income tax exemption and other things, and I am sure your journal is also will be doing very well, and it will get impact factor, not only national but international impact factor soon, because you are dynamic and you know how to get the things in proper directions. So hearty congratulations from me as well as from the institutes, Indian Institute of Soil Science. And this program, particularly on the training program, which is on soil health management concept and practices, very, very important. Though we are talking quite some time now, since the International Year of Soils 2015, and then every year we celebrate in a very mega scale throughout the country, and you are also actively participating. So a very important subject, and particularly in this from the International Year of Soils, a lot of awareness has happened, and we also tried our best to create at national and international levels. As a result, we got also award in 2020 on 5th December, World Soil Day, King Phumibol World Soil Day Award. And that is not only our institute, but we are happy that our council also got name, and not only our council, but our country also got name, that the government is doing a right work in a very right directions. The soil health cards, it is our honorable Prime Minister's vision. As a result, a lot of work has been done. A lot of laboratories have been established. More than 20 crores of soil health cards have been given to the farmers. There are many good things, but there are certain things which is to be taken care of. The main thing is that a lot of awareness in this process has happened. Now every farmers, they know that what is soil health, and what should we do to save our soil. We all know the soils facing a lot of problems, and these problems are, we know that soil degradation is a major problem, and about 1/3 of global soils are degraded. And in India, about 120 million hectares of soils degraded at various levels. So this is a very serious concern, and it is a global problem. Among the, if we look into what are the major challenges of the world, and this is one, the soil degradations, land degradations is a major problem, climate change, another problem, and the declining biodiversity is another problem. And all these three problems, the challenges, they are, they're all linked to one affecting the another one. So this is a vicious cycle. If there is a soil degradation, that also contributing to climate change, and so also declining the biodiversity, above ground biodiversity as well as the below ground biodiversity. Above ground biodiversity, we see, different plants are getting extinct, animals getting extinct, and we are very much concerned. But the below ground biodiversity, which is one of the major components of soil health, we often do not know what is happening. This is like a black box. We are still a long way to go to decipher the soil biodiversity, the below ground biodiversity. All those things I'm sure you will be discussing in this, the program, and there are good experts, they will be telling. And the main purpose that to make awareness, to tell the potential technologies which can be helpful for rehabilitations, rejuvenation, rebuilding the degraded soil, vitalize the soil health, the main purpose. We all know more than 95% food comes from soil. And also more than 90% of antibiotics are from soils. So the importance of soil is enormous. Without soil, we cannot think agriculture. Soil cannot be created in the laboratories. We cannot make soil. It is the natural phenomena, nature's gift. We must use it with all cares, with all precautions, with soil building, soil saving technologies. So much so that its health is sustained, its capacity to produce food is sustained, and it is built up, not only sustained, it is to improve. One of the major problems, soil erosion, that is the removal of fertile topsoil. And this occurs, we all know, through rain, wind, and tillage. And about 5.3 billion tons of soil eroded every year, taking away 8 million tons of nutrients. And as I told you, more than 1/3 of soil is degraded. Every 5 seconds, the equivalent to 1 football ground of soil is eroded. It is as per FAO's data observations. Our cultivated land, 104 million hectares, is degraded at different levels out of 140 million hectares, 140 or 42. So these are many concerns, and we are working in this direction. Many issues, organic carbon decline, less than 0.5%, you all know. Emerging multi-nutrients deficiencies. During our independence, it was nitrogen. Now more than 10 nutrients are deficient in different soils. Among those, zinc at various levels. In some states, more than 50% soils are zinc deficient. Boron, sulfur. So our institute developed the soil fertility maps of the country, and more recently the micronutrients maps. About 640 micronutrients maps of the country, E-Atlas, has been published. And it is a very serious concern, the picture of micronutrients status of the country. And until and unless we put these micronutrients along with the macronutrients in balanced proportions. As a soil scientist, we all know we cannot achieve the targeted yields. We cannot. The varieties may be highly potential, but the yields cannot be realized until unless the balanced fertilizers are used. So what is the need? Soil testing, then find out the status, apply the macro and micronutrients along with organic manures, biofertilizers, all the organic approaches to be integrated. So integrated nutrient management based upon soil testing, and it should be balanced. So this is very, very important. That is what we were recommending. Recently, more recently, we are talking now natural farming. Organic farming practices was also going on in niche areas, but now along with that, the natural farming. The concern is that we need to save our soil. We need to sustain our soil so that its production capability is maintained. So in this direction, all these different packages, approaches is to protect our soil, maintain its health, sustain its productivity, and all kind of things. So in this training program, I'm sure you will be addressing different aspects. Soil health is being, affected by soil pollutions. That is another aspect. And that is, different ways our soil is getting contaminated. Solid and liquid waste, contaminating land with salts, heavy metals, and organic pollutants. And you may be knowing that more than 2 million tons of e-waste, another e-waste also getting generated every year, and about 10 million tons of plastic waste every year. And during COVID time, lot of plastics which has been incorporated because contaminated plastics and all gone buried below the soil. What will be their transformations? Different kinds of chemicals, everything going to the ultimately, if it is not properly disposed, very, very chances are there that it will go, part of that will go to the soils. And that will be, creating not only the soil health, but the human health. So pollution is another concern, which is creating problem, declining soil biodiversity, that is also creating. So the resistance and resilience of the soil, because of all these overuse, misuse, contamination, this and that, is creating problem. And as a result, disease suppressive, the soils having enormous capacity to suppress the diseases. That functions many of us perhaps not studied, not very clearly known. So we have made a critical review on that. Disease suppressive soils, which is beyond the food productions. And in this training program, I'm sure some of you will also touch all those points. Very, very important things when we talk about the enhancing soil health. Now regenerative agriculture, natural farming, whatever it is, one is that keep the soil covered, crop residues, cover crops, because soil erosion is a major problem. And if that erosion to be stopped, we have to keep our soil covered. Earlier time, when it was a natural ecosystems, all the things were taken care of. In natural ecosystems, there were vegetations, everything. So as a result, the erosion was very, very less, minimum erosion. And when natural ecosystems, above ground biodiversity, because different kind of trees, plants, all sorts of things happen. As a result, the below ground biodiversity was also abundant, and there was no problem in the soil functions. But because we are going for monocropping, double cropping, and all kind of things, and intensive, as a result, many problems are coming. Intensive everything. You give fertilizer, we give fertilizers many a times, which is not judicious. We putting a lot of pesticides, not judiciously, giving herbicides non-judiciously. So as a result, the problems are getting multifold. So there are a lot of science, lot of experiments, lot of informations are available. All those given a lot of proofs that if there is a balanced application of all these, soil will not be affected. Long-term fertilizers we have at our institute, different centers, about 20 centers, clearly shown the soil health will not be affected if there is a balanced fertilization, along with farmyard manure, which is about now 50 years. So there is enough proof. Then, integrated farming systems, maintain, integrated systems, soil, crop, livestock, interactions. That will be very much needed if we want to keep our soil healthy. Maintain living roots around the year, living root. So there are many approaches, technologies, which should be adopted. The technology landscape we have got. Nowadays, the conservation agriculture, another very important. A lot of advantages we have seen. It is now long-term fertilizer experiment, long-term experiments on conservation agriculture. A lot of benefits on the soil health throughout the country being demonstrated. We have got a consortium research platform on conservation agriculture at 11 centers. New biofertilizers, microbial consortia, that also a lot of work has been done. So all those knowledge has to be put for site-specific agroecosystems, crop, soil-based systems, so that the maximum economic advantages for increasing the yields of the crops, economic benefits from the crops can be taken, as well as our aim, our goal to save the natural resources can be obtained. Technologies for rapid recycling of organic residues, crop residues developed. At IRI, we all know Pusa decomposers, so also our institutes. And we have tested it at New Delhi. So there are at Central Soil Research Institutes, many good technologies have been developed, and that has to be taken to the farmer fields. Nowadays, we are talking about the nanotechnology also, how best it can be used in this package of practices, whether it should be applied at the top dressing, at what interval, how much to be applied, so that the crop yields can be enhanced. At the same time, our soil nutrients not depleted. So that is also another area in this direction of soil health, conservations, and practices. I told you about the balanced fertilizers, another thing. So site-specific integrated nutrient management of natural resources are very, very important in the present time. Lot of studies we have made about the benefits of integrated nutrient management in terms of its energy, budgets, and other things. So this program the academy is organizing is, I should say, wonderful. The trainees from different parts of the country you have joined. So hearty congratulations to you that you could make it to participate in this. And I'm sure the experts from the different parts, they will give their best from their research, from their experience, and that will be very much helpful to each of you, and which is necessary in the present time. Many such trainings, is required on site, off site, and because if you come physical mode, that is will be further helpful in terms of seeing and believing, to see the laboratories, interact with the scientists, sit with them, get their feedback, and then keep in touch with them. And that is very necessary. So, Dr. Arora Saab, hearty congratulations to you and the President Saab, the Academy as a whole. You are doing excellent work, efforts in this direction, to sensitizing, to make mass awareness, to tell the technologies through different experts. And I'm sure in these trainings, different, though it was not possible to introduce, to know them, who are they, what they are doing, why they joined in this course. I'm sure the purpose is to save our soil. Healthy soil is a healthy life. There are many, on the many themes, Food and Agriculture organizations conduct the World Soil Day every year, and all those themes, whether to halt the soil's salinization and boost the soil productivity, which was the last year, stop soil erosion, and protect the soil. So like that, every slogan, every theme has its impact on the, to save our soil and to improve the soil health, improve the productivity for a country like India, where we have got limited land area, 140 plus minus 2 million hectares. Degradation is rampant. So we need immediate actions. Actions is very much necessary. By 2050, our food requirement will be more than 400 million tons. Our population will be 1.7 billion populations. And not only now our country to feed its population, but also to feed many parts of the world. And all these things will happen.
Excuse me, sir, you have been muted somehow. Sir, please unmute yourself. Dr. Patra, sir, please unmute yourself.
I do not know how it happened. Sorry. So I did not do, but it automatically happened. Or maybe the host is by mistake. So what I was telling, that our target is a huge, from 140 million hectares, produce more than 400 million tons to feed 1.7 billion population of the country. And not only our country, many parts of the world. And in this COVID time, you have seen there is a lot of demand. So that is why world is watching us. World is getting confidence on us, and our role is to produce more to feed the world. And that is possible. One side, save our soil, and for that, all different technologies to be integrated, so that the nutrients feed the soil with nutrients, so that it will supply nutrients to the crops. So the whole gamut of the today's presentations, deliberations of this program is very much in that direction. So hearty congratulations to each of you joining on a very important subject, and particularly to the academy. I am really thankful to give me some time to speak on this occasion. Thank you very much to each of you. Namaskar, Jai Hind.
Thank you, sir. Thank you for setting the pace and setting the stage for the the training program. You have very well put up the status of the soil health, the work you have done during last many years, the future challenges on soil health and soil fertility management, especially for the future generations. So we are also trying that the speakers or the resource person should be addressing these points in their presentations. And sir, we have tried that the basic knowledge, basic concepts, the methodologies, and the approaches to be discussed during the training program, as we have 243 registered participants, and among that 181 are students from different universities and institutes, and especially some means most of them are from agriculture background, and some are from basic sciences, especially environment science, forestry, horticulture also. Uh, uh, 47 faculty members have also registered, and that are mainly from KVKs and private universities and organizations. Some of actually it was a national program, but somehow we got 5 international participants who have requested, who were earlier joining our events, and have requested to be part of our program from Bangladesh, Egypt, and Iran. So we have also consented to be the consented to join this program. Thank you very much, sir, for sparing your time, especially on Sunday. Also, we have disturbed you, but we are enlightened with your brief introduction about the soil health, and how, because you were the main the main institute of India, the pioneer in the soil health management, and we wanted that some brief insights on soil health management from your side. And thank you for giving good talk and address and inaugurating the training program. Thank you very much, sir. I request Dr. Pradeep Kumar Rai, Professor of Soil Science from Sher-e Kashmir University of Agriculture Science and Technology, Jammu, and who is course director of this training program. I request him for formal vote of thanks. Dr. Rai.
Thank you, Dr. Arora, and a very good morning to all. And I take this opportunity to thank our chief guest of the inaugural function, Dr. A.K. Patra sir, Director, Indian Institute of Soil Science, who spared his valuable time and enlightened us with his vast experience and wisdom. Thank you very much, sir. I am thankful to the resource person who kindly accepted to share their knowledge with participants.
सर्टिफिकेट नहीं मिल पाएगा तो सर्टिफिकेट आपको मिल जाता है रजिस्ट्रेशन।
डॉक्टर राय अनम्यूट कर लीजिए, वो गलती से हो गया क्योंकि डिस्टरबेंस आ रहा था बीच। डॉक्टर राय।
Yeah, please. Now I take this opportunity to thank our chief guest, Dr. A.K. Patra sir, Director, Indian Institute of Soil Science, who spared his valuable time and enlightened us with his vast experience and wisdom. Thank you very much, sir. I am thankful to the resource person who kindly accepted our request to share their knowledge with the participants. My special thanks goes to the very enthusiastic participants of this training program who joined us online from Kashmir to Kanyakumari. Personally, I am grateful to the President and Secretary of ANRCM for allowing me to serve as a course director in this training program. And I hope that the participant will find this training program extremely beneficial for them. So once again, thank you and thanks a lot.
Thank you, Dr. Rai. So we will be moving towards the technical sessions of this training, 3 days training program. As per the technical program that has already been circulated to all the participants, the overview of soil health management will be discussed by Dr. Anshuman Kohli, who is Professor of Soil Science from Department of Soil Science and Agriculture Chemistry, BAU Sabor, Bihar. He did his PhD, Masters from Pantnagar, GB Pant University of Agriculture Science and Technology, Pantnagar, and then did his PhD from PAU Ludhiana. And after that, he joined SQUAST Jammu as assistant professor and scientist at the regional station. And thereafter, he moved to Sabor as associate professor, and now he's a professor, and he's a dynamic soil scientist, basically working in the field of soil nutrient management as well as conservation. So I think he will be, he has guided several students in the field of soil health management, and his deliberation and talk will be very useful for the participants. I request the participant to keep their microphone mute during joining or during the program, because disturbance created by one or two will distract the other participants from learning. Actually, we are more we are trying that everyone should get involved in this training program. There will be a session or discussion session in which we will be discussing your queries, your any doubts. So that can be discussed during that session. So during the deliberations and presentation, I request all of you to keep your microphone on off mode, and we will be having a question answer session at the end of the day, during discussions, and afternoon also there will be a discussion session. So thank you one and all for joining. I request Dr. Anshuman Kohli to kindly deliver your talk and discussion. Dr. Kohli.
Thank you, Dr. Arora. Thank you, Dr. P.K. Rai, for providing me this opportunity. Before I begin, I would also like to thank the Academy of Natural Resource Conservation and Management, Lucknow, for providing this platform for the benefit of students, as well as providing me a platform to interact with all of you. So, Dr. Arora, can you please enable screen sharing? Am I audible?
Now check, Dr. Kohli, now you can check.
Yeah, I will check. Okay. Okay, so is the screen visible?
Yes, sir, but not in slide mode, sir.
Yeah, I'm doing that.
Unshare and share again, Dr. Kohli.
Is it visible now?
No, please.
Unshare and share it again. Dr. Kohli, any difficulty?
No.
Uh,
Okay, so okay, so I hope now my screen is visible in full screen mode.
नहीं ठीक है चलने दीजिए, वो वैसे फुल तो नहीं आया है, पर साइड से आपको मूव करना पड़ेगा। देखिए, चलिए करिए।
Okay. Do you see my second slide now,
No,
or I'm still on
no,
the first slide?
no, it is stuck on first.
Okay, so I will have to move it manually by going to by coming out of the full screen mode. Okay,
Yes.
so let me start now. So I'm here to discuss with you about an overview of soil health management. Now you see, as all of you know, since long that we have been talking about our health. Okay, it's always said that health is very important, and as per the definition of World Health Organization, health is not merely the absence of a disease or deformity. It is the state of complete well-being. So taking this corollary to the soil health too should be not only the absence of any disease or deformity, but a state of complete well-being for the soil in terms of the soil being able to perform all its designated functions. So I mean to say that if the soil is able to perform all its desired functions to its fullest capacity, we identify that soil to be healthy. And if these functions get impaired to a certain extent, by whatsoever reason, they are signs of some sort of a soil problem or a deformity. Okay.
डॉक्टर आरएस छोटी ने ज्वाइन कर रखा है, क्या बात है।
So if we try to put up a sort of a definition of soil health, it may be defined as the continued capacity of a soil to function as a vital living ecosystem that sustains plants, animals, and humans. It is the ability of a soil to maintain or enhance water and air quality and thus sustain and support human health and habitation. So you see, soil health is considered in terms of its ability, first of all, to sustain primary production by plants and then the productivity of animals while keeping a healthy diversity in the system. And at the same time, soil health is also visualized in terms of its ability to maintain or enhance the water and air quality as well as support human health and habitation. So this health is also perceived in terms of benefits to the human beings. Now, healthy soils give us a cleaner environment and improved agricultural production. This is what is a general perception. We can always perceive a healthy soil, or let's say that we can always perceive that a particular soil is healthy if it gives us good production. This is a very broad yardstick, but then there are some other nitty-gritties which I'll go into further details in my subsequent slides. As I said, healthy soils give us a cleaner environment and improved agricultural practices. But at the same time, soil health always implies relative to its environment. It's not anything absolute. It's always relative. Say, for instance, there are 2 or 3 similar soils. Okay, and they are existing in diverse environments. Okay, suppose the soils, their physical, biological, and chemical parameters are same, but they are existing in different environments. So these soils, if they are existing in different environments, they won't be considered or rated on a similar scale in terms of soil health. Why? So for instance, if you have a particular soil in an arid environment and a similar soil in a humid environment. So for a soil to be existing in an arid environment, if it has got a very high drainage, probably that is not beneficial. Whereas for a very humid environment, it could be beneficial. So this thing is always relative. Okay, once you understand, once you go through all the details, you also appreciate this, that the concept of soil health is always talked of in a relative term. Now then, there are two almost synonymous terms, soil health versus soil quality. Okay, they are often used interchangeably, but I believe that the two are distinct in the sense that soil health is used primarily when we intend to convey the meaning for the farming community and the generalists. Whereas soil quality is used to convey the intended meaning, I mean the meaning that we defined, like we defined in the first slide, then when it's being discussed in a strictly scientific context. So when we are discussing in a scientific forum, probably the better word would be soil quality. But when you are trying to understand for a very general gathering or an audience like this class, it will be better to consider it as soil health. But at the same time, remember that this soil health and soil quality are somewhat similar and they can be used interchangeably. Another difference which you must perceive, at least after you have completed this course, is that soil health is usually a more qualitative parameter. I mean, there are several other parameters for soil health, but then if you consider soil health as a parameter, it is more of a qualitative parameter because we are talking with generalists. But soil quality is something which is often quantified in terms of soil quality indicators and indices, and then interpreted. So if you say, if you intend to maybe like rank the soils in terms of its increasing or decreasing quality parameters, you can do so. But soil health is like, we can always say that a soil is healthy or poor, but that will always be in a relative sense. Okay, but in case of soil quality, it's possible to define a particular numerical value. We can always assign a numerical value if we choose particular quality indicators or indices. Then another term which we often encounter while talking about soil health is soil health management and soil management per se. So what is soil management and what is soil, how is it different from, or what is it short from soil health management? Now the activities to ascertain and improve soil health primarily involve soil health assessment. This is another thing which I would like to come to. If we think of soil health assessment, this implies determining the status of a soil with respect to its capacity to perform its vital functions. So, as I said, this is more of a assessment of soil quality rather than soil health. But then because these are used interchangeably, so I'll use it as soil health assessment, But when you are assessing it qualitatively in a lab, that is where we often use the term soil quality. But if we speak of soil health management, then this implies performing on-farm operations, the actual field activities that have a bearing either in the short term or maybe even up to a longer term on the capacity of a soil to perform any or all of its designated functions. So you see, in assessment, what we do, we try to find out certain parameters, quantify them, and then we can judge the health of a soil or even quantify the health of a soil. But in case of management, what we do is that we try to, or not try only, actually we perform all those activities that are field operations. But when they are performed with a background in our mind of sustainability and of improving the soil's ability to perform its vital functions, then that is soil health management. So now I should come back to the previous slide which I was discussing. How this soil management is different from soil management. Okay, as I said just now, that soil health, while discussing soil health management, we have a background. We have a background idea that whatever we are doing should be improving the capacity of a soil or the ability of a soil to perform its desired function. But soil management as such just involves manipulating the soil to put it to various uses. Some of these could be beneficial, while the others could be harmful for the sustainability of the soils. So we do not consider that. Like all those farmers who are putting their soils to various uses, even a person who is building a road is putting the soil to some use. They are managing this soil as a resource. But when we talk of soil health management, we have an idea in the background of our mind that whatever operations we are doing should be able to improve the ability of a soil to perform its designated or the desired function. Now, as I have to give you a brief overview of soil health, so let's take a look at soil health issues that we encounter in India. Land degradation. Of about 141 million hectares, we have 104.2 million hectares that is at various levels of degradation. Soil erosion, wind erosion, salinity and acidity, these are the major types of soil degradation that we encounter. If we talk about the average annual soil loss, almost about 5.3 billion tons of soil is lost every year. And this entails nutrient losses to the extent of about 8 million tons, with an average annual soil loss of 16.4 tons per hectare. You can always have an idea what sort of degradation and soil health issues our country is facing. We have 89.5 million hectares in our country which are facing some sort of physical constraints, and along with this, the crop production losses are there because of various types of degradation. Water erosion, salinity, alkalinity, wind erosion, they all lead to crop production losses. So this exactly is perceivable by each and every one of us, at least those stakeholders who are into this business. If we further try to see what are the health issues, soil health issues in India, the reason parameter that is of primary concern is that of low soil organic carbon. There are multi-nutrient deficiencies that are coming up. Then there is low fertilizer or nutrient use efficiency. We'll try to address in some of the subsequent lectures about how these issues are being addressed or they can be tackled. Then there's a decline in fertilizer response ratio. When the fertilizers, when we started using the fertilizers, we got a huge response for each unit of fertilizer applied, but this is continuously decreasing. This is also almost known to all. I won't go into further detail. Maybe it will be a part of any other detailed presentation. The reason for all these things is that there is imbalanced fertilizer use and inappropriate agricultural practices such as crop residue burning. Then there are other concerns related to soil health, because the soil health is degrading. So there is low farm productivity and profitability. There is an issue of land degradation. As I told you, there are several reasons, several types of soil degradation. There is low water productivity. It's also related to impaired soil health, because if our soil health is poor, the water relations of the soils get affected. You do not get your soils to store enough water, and then the availability of water is also an issue in degraded soils. Then we also talk of climate resilient agriculture and risk management with the perceived climatic changes, loss of tree cover, and deterioration of ecosystem services. These are some major concerns. But then once we start targeting soil health as an issue, one by one we should be able to get solutions for all these problems. These are our concerns, but the primary concern is the degradation of the soil. Soil health issue is of primary concern. Well, if you can target that, all these things will, that addressing of all these concerns will follow naturally. If we see the soil fertility status of Indian soils, we say that most of them are low to medium in nitrogen and phosphorus, and medium to high in potassium. The deficiencies of micronutrients are also decreasing, including that of boron. Almost about 25% of the analyzed samples have been found to be deficient in sulfur also. So you see, if we talk in terms of soil chemical health, a disbalance, an imbalanced use of nutrients, fertilizers is causing all this. At the time when our crops are extracting the nutrients in large amounts, the problems of multi-nutrient deficiencies is increasing, because day by day new nutrients are being found to be deficient. The nutrient consumption pattern is a serious concern, because we are increasing the nutrient consumption, which is although increasing the cost of production, but at the same time it is not at all balanced. It's skewed towards the use of nitrogen, as you can see in this figure, and whatever efforts are being done have till date not been sufficient to bring this nutrient consumption to a more balanced proportion. Then there are low nutrient efficiencies, nutrient use efficiencies. Although research is going on to increase the fertilizer use efficiency or the nutrient use efficiency, but then we are still far from achieving even the achievable nutrient efficiency which is possible with the present level of technologies. So not only is there a need to do further research and devise products or nutrient carriers which can have nutrient use efficiencies, there is a need to educate the masses about appropriate use of the nutrient carriers or the fertilizers, so that the maximum achievable nutrient use efficiency can be achieved at the field level. Then there are several government policies and soil health schemes. So for example, you all might be aware that coating urea with neem oil, then the integrated watershed management program also emphasized various components of soil health. The National Mission for Sustainable Agriculture and the National Mission on Soil Health cards. the Paramparagat Krishi Vikas Yojana, somewhat related to organic farming, and now natural farming is also being promoted. The National Biogas and Manure Management Program, and this nutrient-based subsidy program, which obviously is targeted to make our fertilizer use more balanced, but on a practical scale, this has not given the desired results till date. But this is a major concern, and the efforts are on to achieve. The existing soil health program, just one slide, I'd like to brief you about that. Basically, this is a flagship program of the Government of India with 12 soil parameters being considered. And some modifications have been there in the sampling grid and other things, but this soil health program, as some of you might be working with this or have a close association with this program, they might be aware that despite the efforts and the impetus given by government, this has been a very slow starter. Even if you talk with the stakeholders, they haven't received the actual benefits of the soil testing program. So something else has to be thought about. We need to be aware about the soil health problems. Very simply, we need to be aware about the soil health problems and tackle them at site. This could be one of the solutions. It could be by soil testing. It could be by soil physical management, by organic management, or whatsoever. Then you see, you'll say, what is the use of soil health data? If we get the data related to soil health, how could it be beneficial? So just to appraise you, maybe in some other lecture you'll get detailed information about that. But then if the soil health data of a particular region is available, it's possible to formulate customized fertilizers. It can be used for soil fertility mapping and then for further planning. It can be used for calculating the fertilizer requirements and then distribution. And overall, the standardization of management practices can be done if we have the soil health data. Now, when I say soil health data, I do not mean only about the soil fertility status. We need to have comprehensive information about soil health, including its physical health and biological health. If we see the world soil conditions, we find that the soils are increasingly degraded in many regions. This red marked area is increasing worldwide. And this is of concern. And we all need to make concerted efforts to arrest this. Okay. So now we come to what makes a soil healthy. Okay. We understood what is soil health, what are the problems that soils or the issues that are of concern in case of soil health. But then what does make a soil healthy? How do you make soil healthy? How does a farmer, what does a farmer do to make his soil healthy? So to make this understand, let's see, the soil, which basically consists of 4 components: air, water, minerals, and organic materials. The soil can change its state of health if any of these components changes. If the proportion of any of these components in the soil changes, we'll definitely have a change in the soil health status. It could be for better or for worse. And how do these changes occur? These changes do occur with normal soil management interventions: tillage, plowing, irrigation, fertilizer application, reclamation, crop production. Any management practice that we do on the soil would change the relative proportion of these 4 components, and thus has a potential to make our soil healthy or filthy. So soil health management would then involve not only optimizing the specific management intervention. Say, for example, if we find that a soil is being compacted because of the use of heavy machinery, we don't have to target only that component, like using that heavy machinery. Okay, we can also overcome that limitation or that shortcoming by optimizing other factors, such as application of organic materials, reducing tillage operations, or changing the frequency of irrigation, or maybe choosing a different cropping system. Keeping in mind that whatever we do, whatever management intervention we do with a background of soil health management, that should be able to provide a greater resilience to the soil. You see, the soil as it exists always has a capacity to revert back to its initial state. But what we should provide is an opportunity for the soil to do that. We should just be able to provide an opportunity to the soil to get back to its original state. The ability of a soil to get back to that original state is its resilience. All soils have this. But then if we can, if suppose the problem is of compaction, we can target it by not only targeting the specific management intervention that resulted in that problem, but by providing other congenial inputs that can boost the resilience of the soil. So with this background, let's take a look at soil biological health. Now, although not so apparent to the naked eye, a healthy soil is a dynamic living system that is teeming with life. A healthy soil that promotes a healthy soil food web would thus have these characteristics which I have listed. So all the organisms that a plant requires are present and functioning. Microorganisms, macroorganisms, symbionts, asymbiotic microorganisms, decomposers, all sorts of organisms should be there in the soil. The population could change with time. At times it is more, at times it is less. It is varying with the stage, during the life cycle of the plant. But then this cycle is also important. The nutrients in the soil, they should be in the proper form. And the cycling of nutrients is important. The correct ratio of various soil microorganisms is important. If this is all present in optimum, then we say that the soil is healthy in its biological state, or we say that a soil is having a good biological health. And then before I end, some words about soil physical health. You see, as I told you that the relative composition of soil in terms of 3 phases is variable within certain limits for a healthy soil. We cannot say that this particular bulk density is for a healthy soil. A range of that bulk density can be accepted for a healthy soil. And again, as I told you in the first few slides, that soil health is on a relative scale, not an absolute scale. So what is its bulk density? Whether it is a healthy bulk density or not, it has to be seen in a relative context, in the context of what use a soil is being put to. So if we consider soil as a physical entity, a soil can be considered healthy if all its intrinsic parameters characterizing the state and movement of matter and energy within the soil, as well as across its boundaries, are within the acceptable limits. These acceptable limits can be site-specific, as I said. They are always relative to the use the soil is being put to. And to consider all physical aspects of soil, we may well consider 5 senses of the soil interface. Like we have 5 senses, sight. Okay. So for soil, we can sense the soil through its color. Okay. What color a soil is also tells us something about the state of its health. Then another sense is touch. So by touch, you can feel the texture, structure, friability of a soil. And with this also you can judge what is the state of soil health. Then smell. Obviously soil should not be giving smells, but then you see if a soil is just after the rains, if you get that stony smell because of those soil actinomycetes, which give that particular flavor, geosmin. So that means that the soil is active, biologically active. But then in physical terms, if you can you can smell that, this itself says that the soil is good. Next, our sense is hearing. And a healthy soil hosts a large number of organisms which make the soil audible. So when I say hearing, I am saying that physically the soil should be able to provide habitat for soil macro and microorganisms. And then taste. Though not explored in terms of the taste to the human tongue, the health benefits of pedophagy have been documented for humans and animals. And also the indirect interpretation in terms of pH and EC, which can be considered indicative of the soreness and salt or salinity. And besides, the ability to produce a bumper crop is also an indicator which is just like a taste-like perception. So you see, soil physical health is because of different reasons, but then we need to perceive this, and it's our judgment how we perceive this, and then how we modify the production practices to suit our purpose of improving soil health. So then what are there are some indicators of soil physical health. I've already listed this earlier, talked about these earlier, but then I'll just have a fast recap. Soil color, then structure and micropores, bulk density, how deep is that soil, water holding capacity, retention and transport of water and nutrients, the productivity potential, soil compaction, what is the depth of the flow pan, water movement, how fast water moves, or for how long does water stagnate, the porosity and workability, which obviously the farmers find that whether a soil is hard to tell or easy to tell. So before I end, with whatever I said, that I'll just say that these are some of the management practices, not a comprehensive list, that can potentially improve the health of our soils. There can be various other options, and some of the options are already included in your list of lectures here. These management practices could include reducing inversion traffic or soil tillage. We are often talking about zero tillage or minimum tillage. Then increasing the organic matter inputs. Obviously, you see, we do not have organic matter always, but then whatever organic matter is available, that should be used in the soil, that should be put into the soil for improving the soil health, using cover crops and rationally using the pesticides, rotation of crops, and ultimately the managing various nutrient sources is the key towards better soil health. I think that's all on my side. Over to you, Dr. Rai.
Yeah, thank you, Dr. Kohli. And this is a very informative lecture for all. and you have discussed a lot of things which will be detailed in discussed in a later session by individual experts. So you have rightly said that not only physical or chemical, but biological property of soil is very important for the soil health. So now, thank you very much, Dr. Kohli. And the question answer session will be discussed after the second lecture. So now I would like to
Yes,
invite.
I'm here, and whenever after the next lecture, we'll be here for this discussion.
Yeah, sure. So now I request Dr. Sanjay Arora for delivering his talk. So Dr. Sanjay Arora is presently working as a principal scientist at IECR, Center Soil Sanitary Research Institute. He has been recently elected as a vice chairman of Commission 3.6, Salt Affected Soils Control, Remediation and Reclamation of International Union of Soil Science, IUSS, which is a very big achievement. He had made significant scientific contribution in bioremediation and management of saline and sodic inland and coastal soils. He has developed innovative microbial formulations for bioremediation of salt-affected soils for enhancing crop productivity under salt stress. Evolved agroforestry and multi-purpose tree-based restoration of degraded salty lands. He has developed decision support system for chemical reclamation of sodic soils like GIPCOL mobile application, which is very popular, and has modified and refined the laboratory protocol for estimating gypsum requirement of sodic soils. He has published 167 peer-reviewed research papers and technical articles with more than 2,000 citations. He had edited 14 books, guided 12 master's students and 2 doctoral research. Presently, he is the chief editor of Journal of Soil and Water Conservation India. He is elected counselor of World Association of Soil and Water Conservation, Beijing, China. And he is also the member of FAO INSAS as soil sanitary expert. So with his vast experience, I request Dr. Sanjay Arora to please deliver his talk on the methodologies of soil health assessment. So Dr. Arora, please.
Thank you, Dr. Rai, for a nice introduction. So dear participants, we will be discussing on the different methodologies, especially the laboratory methodologies, the approaches on soil health management. As Dr. Kohli in his lecture has briefed about various concepts and the indicators, or say means the soil properties that influences the soil biological, physical and chemical health. So on that same line, we will be discussing on the methodologies that can be adopted in laboratory or say assessment, and especially soil health management, as well as how to manage the sodic soils, what are the indicators for that, and how it can be possible to manage these problematic soils. So this is the topic, methodologies for soil health assessment. I am from Central Soil Salinity Research Institute, Regional Station, Lucknow. So what is soil? This is we are discussing because I have seen that most of the participants are from different fields, maybe from agriculture background, but not in soil science, or from environment science and many other streams. So soil is a three-dimensional body. We say it is a naturally occurring body, which get influenced by climate, organism acting on that, and how it is formed. It is basic, because whenever you are going to manage the soil, we should know how it is formed. It is formed by weathering. There are several soil forming processes: physical disintegration, chemical decomposition, biological disintegration, and these all processes are involved, and it takes a lot of time to develop a soil. In the form of a soil profile, we see the zone where the organic matter is sufficient for the plant growth, the clay content, the nutrient means storage, and all these things, because soil not only provide nutrient, it also provide congenial environment for transformation of nutrients from one form to other. They provide means residing of the organism in their means habitat, as well as water which is required by the plants. If we see how these soils are formed, basically these soils are formed by the action of water, by the action of wind, gravity, or in some areas ice is the agent. When these soils, the deposits from disintegration of parent material, especially from the rocks, minerals, and all that, they form with the action of water. We see that if the river it is transported, then the alluvium is deposited and we get the alluvial soil. And similarly with the lake, lacustrine soils, and the ocean, the marine soils, the wind action results in formation of dunes, and similarly the gravity action and the ice action form different soils. So composition or the native composition of the soil depends upon the parent material, the agencies involved, and the time taken for the deposition and transformation, and the pedogenic processes, which includes gain and addition. Gain and addition means we are during the formation, water is gained, oxygen is added, organic and mineral matter are added to the soil, and the solar energy, which is important to give life to the soil as a whole, including the microbes, the root, and the losses, basically the water by evaporation and soil by erosion or degradation, and CO2 or carbon dioxide through organic matter oxidation. And there are several transformations from weathering of minerals to production of organic acids and structural development, and we see translocation of clay, organic matter, and hydrous oxides in the form of elevation or illuviation, which results in the total pedogenic processes that occur in the formation of soil and development. Several processes that results in, as I told you, the native composition or classification of that soil, what is the type of the soil, how much nutrient it is containing, whether it is suitable for agriculture or not. This all depends upon the process through which the soil has been formed, especially the calcification, where calcium carbonate is or calcium mineral is dominating, decalcification, where calcium losses are there, podzolization, laterization, salinization, where salinity, the soil you get the basically having saline conditions and having the dominance of calcium and magnesium, sulfate and chlorides, and alkalinization, where the pH of the soil is mostly high, where the alkali salts are present, and pedoturbation, where there is turbation of or the transformation of clay from surface to other. And we see that some of the ions, especially the cations and anions, which are dominated in the soils, these are present in the soil through the native mineral through which it is formed, and potassium, calcium, magnesium, zinc, manganese, iron, copper, and ammonium, while anions include nitrate, sulfate, phosphate, borate, molybdate, and chloride. And all these mostly are required for the plant growth. And when these are present in through the transformation and during the process of development, they are sufficient to sustain the productivity or growth of the vegetation. But during past few years, we are seeing that although soil is delivering its goods and services to humans and environment, because they provide biomass, every food or fodder or raw materials, whatever you think about, comes from the soil. The renewable energy, the importance of soil is based means on these the power of the soil to provide these. Soil provides strong and storing and cycling of nutrients and other elements within the Earth's biosphere, as Dr. Patra in his inaugural address already has described how soil is important not only for our food, not only for our needs, but also for antibiotics, for medicinal purposes. The soil is required. Soil microbial population which is important in not only enzyme production of certain antibiotics, certain antioxidants, and this is important. So we have to care for the soil to sustain the human health as well as the environment. The pollutants, whenever added to soil, the soil has the buffering capacity. They provide filters, they provide detoxification of the pollutants. And also, if we are adding the water to the soil for crop growth, if it has certain heavy metals or certain toxicants, it can be detoxified during due course with the action of soil. Soil provide a sink for the carbon, and it regulates the carbon cycle in nature, which is very essential for the human life also, and soil maintaining flora and fauna, which guarantees the biodiversity, which is important for the nature. Since the Green Revolution, we have seen that there has been gains in food production. We have come from 1950 to 2020. If we see, the population has increased drastically, not only in India, but globally. And the food production from the soil has been means taken to certain heights, where we can see at present that we are self-sufficient in food production. And not only that, in the present era, when there are wars going on in different parts of the globe, India is the country providing food to many of the nations. So in that situation, it is very impressive that our food production has gained, but that has been possible only through the exploitation of soil resource, water resource, and basic is the soil. And we have to revitalize it to, if we want further such food production, the quantities of 400 million ton, as Dr. Patra was saying, by 2050, we will be having the need of more than 400 million ton, and presently 320 we have achieved after a lot of efforts by not only the scientists, academician, as well as mainly with the efforts of the farming community. With agriculture expansion came the soil degradation. Whenever we are expanding our agriculture system, soil degradation will be there. It will be causing degradation either in terms of chemical degradation or say certain addition of pollutants, or if their development occurs, real estate will take over the soil, agriculture soil, and sometimes we are seeing erosion due to different actions. With use of fertilizers and agrochemicals, environmental pollution results in soil pollution. With increase in irrigation and over-irrigation in the agriculture field results in soil salinization, and also due to seepage from the canal system, we are seeing that soil salinity is occurring. And this problem, when comes to the soil health will deteriorate, and ultimately production will be reduced. Emission of CO2 into the atmosphere due to deforestation and excessive plowing and use of certain improper technologies results in emission of CO2 into the atmosphere, bringing loss of carbon from the soil system to the atmosphere. Excessive reliance on the fossil fuel energy with increase in production have resulted in, although there is increase in production, but there is a chance that of the reduction in the soil health. Dr. Kohli has already described the capacity of the soil to function within ecosystem boundaries to sustain biological productivity, maintain environmental quality, and promote plant and animal health. This is the basic definition of the soil health. And in the context of agriculture, if we see, it refers to its ability to sustain productivity. Means whatever the soil can provide to the environment, to the agriculture system, it should be sustainable. Means then only we can say the soil health is maintained. Healthy soil should ensure proper retention and release of water, nutrients, promote and sustain root growth, maintain soil biotic habitat, respond to management, and resist degradation. Actually, soil quality and soil health are interlinked, as well as environmental quality and agriculture sustainability, because chemical, physical, and biological factors which influences the soil quality results in environmental quality, especially air quality, water quality, as well as soil quality. And if these environmental qualities maintained, we will be getting the agriculture sustainability in terms of economic, social, and environmental quality. So this is the means how the soil health is important, why we need to focus on the soil health. This was the basic agenda which we have put during my previous slides. And what are the indicators of soil health? Means if we say a healthy soil, what does it mean? It means it is having a good soil organic carbon content. Means soil organic matter is the indicator which helps in retention of nutrients, soil fertility, soil structure, soil stability, and soil erosion. This has the direct relationship with the soil organic carbon. So if the soil is healthy, the health of the soil is basically revolve around the soil organic carbon. The other important aspect, as Dr. Kohli was telling, bulk density, infiltration of water into the soil system, soil structure and macropores, the porosity, because the composition of soil specifically says that ideal soil is having a 25% air as well as 25% water in their pores. And if that ratio changes, sometimes the soil health deteriorates. So physical property governs many of these, especially the texture where the means the proportion of sand, silt, and clay particles, which governs the bulk density, which also affects the infiltration of water, and retention and transport of water and nutrients will occur only when the bulk means the physical properties are improved. Habitat for soil microbes has because microbial population needs aeration, proper moisture. So in the soil system, if the physical properties are also affecting the soil health. In terms of chemical indicators for soil health, we include electrical conductivity, reactive carbon, soil nitrate, soil pH, and extractable phosphorus as well as potassium. These are the apart from the nitrogen and other micronutrients, because biological and chemical activity are the basic component required for the plant growth, and plant available nutrients have the potential to sustain the productivity from the soil. So when we are talking about the biological health of the soil or the biological indicators that govern the health of the soil, the microbial biomass, carbon, the presence of earthworms, the microbial flora, the soil respiration, total soil carbon, as well as mineralizable nitrogen, apart from the particulate organic matter that is available in the soil. These are the indicators of the soil health, especially the biological soil health, which mediates certain processes, activities into the soil, which results in the proper growth and production of crops. All you must be aware that Government of India has initiated soil health card scheme, where we see 12 indicators have been assigned for every soil health card, especially from pH, EC, organic carbon, nitrogen, phosphorus, potassium, sulfur, zinc, iron, manganese, and copper, based on the the requirement of the crop, the dominant cropping system, the soil types which we are having. So if the soil, if these 11 or 12 indicators have been assessed in the laboratory properly, we can certainly improve the health of the soil, sustain the productivity. And for that, laboratory should be well equipped with the basic equipments required for the assessment. We will be discussing on the methodologies, how these can be properly done in the laboratory, although it is an online platform where we will be discussing basic concepts and basic methodologies. However, many of our participants must be knowing the methods, but some of them, especially the students, may get some idea during my talk. Water stable aggregates. It is especially the factor which is, apart from the bulk density, texture, and all that, the water stable aggregates reflects the physical health of the soil. It reflects the soil structure, resistance to erosion, slaking, etc. And it tends to be the stronger with increased clay, and it also gives an idea about the presence of organic matter and what the infiltration into the water infiltration into the soil, proper aeration. Drishti, please do not make certain interruptions during the presentation so that we can go ahead. And water stable aggregates, it is a very means easy process in the lab by using different sieves of different sizes, best size, we say, and the water can be the shaking equipment can be used. It is not very costly, but it can be done easily into the laboratory. And the methods you can get it from any of the manual, but the importance and the concepts we will be discussing here. Bulk density, which increase with the compaction from, say, a roller, or we are using tractor in our machineries, in our fields, and that results in compaction. And when there is compaction, there will be less infiltration of water, movement of air will be restricted. So we are expecting that the basic, the general soil property is the bulk density, and bulk density of normal soil, we expected 1.4 to 1.5 or 1.6 gram per centimeter cube or megagram per meter cube. And this is the means basic physical property which we can assess properly into the soil laboratory or into any of the labs. If the undisturbed soil sample is taken from the field with the help of a soil core, it can be assessed. Or if the soil, if you want to get the idea about the bulk density, how much it is ranging, not an exact figure, but an appropriation can be done by disturbing the disturbed soil sample can also be taken, and in the form of Claude method, or you can simply make it by weighing the amount of soil that is packed into a certain known quantity, known volume of the vessel, and you can get the idea, because it is the mass per unit volume of the especially the dry soil. And increased bulk density is associated with reduced aeration and water infiltration. So whenever you see the bulk density has increased, then it indicates that the soil is having poor aeration, poor in water infiltration. And if it is high, with the addition of organic matter, you can improve it by addition of certain amendments that can be improved by tilling practices. It can be improved. Soil organic carbon. On the basis of color, you can define how rich is your soil in organic carbon content, because organic carbon is derived from the organic matter, whatever the leaf, all the residues, the manures, the compost you are adding to the soil, it will result into the soil organic carbon, and this is a source of major nutrients into the soil. And as I told you, it is the center point of the soil health. And if you are you can physically assess the soil carbon by taking in your hand the soil during your survey programs. You can see if the color of the soil reflects, if the dark color indicates the presence of high amount of organic carbon, and if the yellowish, the soil is yellowish and or say whitish in color, then organic matter is poor. And especially in salt affected soil, the problem is of the hydrolysis of this carbon, and we see that these soils are very poor in organic carbon. Thus, the aeration, thus the aggregation is reduced, because water holding capacity, cation exchange capacity, and all the other properties of the soil are affected by the poor organic carbon. Biological properties also includes the properties can change rapidly, because if you are adding chemical to the soil, the soil biology or the the bacteria, fungi, actinomycetes, the termites, the arthropods, the earthworms, they all will vanish in the times to come if we are using unjudiciously the chemicals, especially the pesticides and herbicides. And when the microbial population is affected, the biological enzyme activity in the soil system will be affected. And these enzymes, different enzymes, represent the decomposition and cycling of nutrients, especially the dehydrogenase activity, which is the overall microbial activity. It will tell you about the overall microbial health of the soil. Nitrogenase fixes the nitrogen, transforms the nitrogen, helps in transformation also. And phosphatase for fixing the nitrogen or phosphorus, how much quantity of phosphorus is being fixed into the soil system. Beta glucosidase indicates about the breakdown of cellulose and other. So these were the basic. In almost all the soil, we have to follow the soil health indicators to be adopted, but especially for salt affected soil, where the formation is very important. If the mineral is dominant in salt, means you are getting the salt from the native minerals from which the soil has been derived, then it is very difficult to manage, because salt move with the percolation and then again come back to the surface of the soil with the capillary movement. And we should know the basic how these soils are formed. When the calcium, magnesium, and potassium is dominating, the salinization, we can see the occurrence of saline soils, especially in the coastal areas or in the areas where the mineral has been developed through the action of different decomposition or disintegration processes, but having high calcium, magnesium, and potassium content in the native minerals. The salinity and sodicity is basically dominant in arid and semi-arid regions and subhumid conditions. And in coastal areas, we see salinity due to seawater ingress also, where the EC is more than 4 deci per meter, and the dominance of chlorides and sulfates of calcium, magnesium, as well as sodium. But the exchangeable sodium is low and the pH is also in control. But if we see the classification of salt affected soil, these are the saline soils, the alkali soil, the saline alkali soil. These three types of soils, we categorize it under the salt affected soils on the basis of pH, sodium adsorption ratio, exchangeable sodium percentage, and electrical conductivity of the saturation extract. The difference between the normal soil and the salt affected soil is we are measuring the salinity in the saturation extract, because sometimes the soluble salts may not be easily extractable in the extractant we are using for determination. So USDA, United States Department of Agriculture, has already defined the system for the salt affected soil. We follow that system only. The electrical conductivity of saline soil is more than 4 deci per meter, and for sodic soil it is less than 4. For saline sodic, it is normally the electrical conductivity of the saturation extract. You please note that ECE means electrical conductivity of the saturation extract. What is saturation extract? We will be discussing in next slides. Exchangeable sodium percentage, where we determine the percentage of the sodium ion which is on the exchange site of the soil surface, soil micelle. And if in comparison with the other cations present in the soil. So if sodium is dominating, we see that sodic soils having more than 15% of exchangeable sodium as compared to other ions. In case of saline soil, it will be less than 15, while in case of saline sodic soil, where EC is also more than 4, but exchangeable sodium is also more than 15. In terms of pH, if we see the pH of the saturation paste, especially PHS, the salinity in saline condition, we see that it is less than 8.5, while in case of sodic soil, it is more than 8.5. If the pH of the soil is more than 8.5, we call this soil as sodic soil, where the exchangeable sodium is high, the pH is high, and we have to target to reduce the exchangeable sodium, and it is very difficult to remove or to exclude sodium from the exchangeable side, while in case of saline soil, where the pH is controlled under 8.5, but electrical conductivity, because of the soluble ions, it is more than 4 decimal per meter, and exchangeable sodium is less, then we can manage easily by the use of water, physical actions, and certain amendment. If we see the dominance of salt-affected soil in India, especially 6.73 million hectare of salt-affected soil is dominating the Indian means overall nation. And sodicity, the sodic soil where the exchangeable sodium percentage is high, more than 15, and EC is less than 4, while pH is more than 8.5, we see 3.77 million hectare of the land is sodic. Saline soils basically nearly 3 million hectare, about 2.96 million hectare, dominating in the coastal system, not only in Gujarat, in West Bengal, Tamil Nadu, Kerala, we see the presence of these. Sometimes the dry land salinity is there in Gujarat as well as Rajasthan, and in arid zone of Ladakh also salinity is there. See the extent of salt affected soils in India. We see the Gujarat is dominating in saline conditions, while in Uttar Pradesh we see high sodic soils amounting to 1.3 million hectare. So these are the basic characters which I just told you. But on the physical basis, we see the color of the soil. The saline soil is especially white to brown, while the organic matter content is slightly less than the normal soil. Development under arid and semi-arid climate, where the rainfall is less than 550 millimeters. Otherwise, in high means in the areas where the rainfall is good, there will be washing of the soluble nutrients. Flocculation occurs, soil structure is optimum, available water is less, and in alkali or sodic condition, we see if the pH is high, EC is less, and soluble salts are less than 1%, and dominant salt is sodium carbonate and bicarbonates. The soils are basically blackish in color, and sometimes if the carbon is excluded due to hydrolysis, the color will change to white. Developed by the process of alkalization and developed under semi-arid and subhumid climatic conditions. A dispersion of clay is common, soil structure is poor, organic matter is very less, and infiltration or water movement is restricted due to dispersion of clay. And in Uttar Pradesh, 39 districts are affected. This is the physical, you can see the salinity and sodicity, how the salt crust is means formed on the surface of the soil. So in these soils, the structure will be poor, there will be poor aeration. So this all will affect the soil health, because when the salt is dominating the soil system, there will be changes in the soil system in terms of pH, in terms of electrical conductivity, dispersion of clay, and this will result in slow permeability, less bacterial activity, poor aeration, and difficulty for agriculture works. Nutrient imbalances will occur because of presence of toxic ions, especially the sodium, calcium, magnesium, and carbonates and bicarbonates. And the crop will be affected to a certain level. There will be sometimes no crop in where high salinity or sodicity is there. And there are certain effects we can see on the when the EC is high, more than 16, very strong saline condition are there. Only few or very tolerant crop plants can be grown. Otherwise, in the under moderate saline conditions, salt tolerant varieties are there that can be grown. So means the soil will be barren if the salt is high. So the soil health will be highly deteriorated under such condition where the pH is more than 8.5 or less than 5.5, where the availability of nutrients such as nitrogen, phosphorus, potassium, sulfur will be affected, especially the micronutrients also in high pH soils, iron deficiency, manganese deficiency. There is fluctuation of boron, copper and zinc will be in low quantities, especially in sodic conditions. How to determine the pH? As I told you, the pH is the scale from 0 to 15, and it tells about the acidity or basicity of the soil. This is just about the basic, you all must be knowing, but you means in the laboratory, you should be very clear uh, about the determination how to measure because you are also measuring the hydrogen ion activity, and as well as the if H ion concentration is more than OH will be means as compared to OH, then the acidic soils will be there. But if the OH is more than the hydrogen ion, then the soils will be basic, and you have to be the concepts as well as the basic uh, idea of determination should be clear, because there are certain approaches which are being used in laboratory for analysis of the soil in terms of pH. As I told you, not only 1:2 soil water ratio, uh, taking 1 gram of soil and 2 ml of water is the ratio. But in laboratory, it is very difficult to test it, because the pH meter having the electrode, the glass electrode, uh, you have to dip it up to 1.2 or 1.5 centimeter, because it is based on the potential change, and that can only be possible if 10 gram of soil or 20 ml of distilled water, which is free of ions, can be used as for preparing the solution, or 1:2.5 in certain areas, but dominantly in salt affected soil we follow 1:2. But when we want to categorize our soil for salinity or sodicity, or for some problematic means parts, then we have to go for the saturation extract or extract as well as the paste. And for that, uh, because it will be giving the idea about the organic carbon as well the organic constituent present in the soil, it will give the idea about the carbon dioxide, the salt content, the exchangeable cations and anions, if proper ratio is maintained. Similarly, the electrical conductivity, the conductance, how the current can be flown from one the ion. The similar is the movement of ion. When we are determining the electrical conductivity, this is basically the movement of electrons, maybe the electrical ions or the nutrient ionic elements. And it is the analysis based on acid or salt soil. There will be difference you can easily assess in the laboratory, where you can predict how much salt is present in the soil, because water soluble ions, especially cations and anions, will be solubilized in the 1:2 ratio, and the electrical conductivity will reflect the presence of dominance of ions. soluble salts, basically the primary effect is the osmotic effect. We see with increasing salts, plant cannot extract water, and when the plant is unable to extract water from the root area or the rhizosphere, then plant will die. The roots have semi-permeable membrane and accept water but not salts. So if the salt is present, it will not allow the salt to come, but the water will be restricted in their movement. A specific ion toxicity will be there, especially chloride and boron under high salt condition when the soluble salts are present. Bicarbonate affects micronutrient uptake, especially iron and zinc. And if saturation paste is used to measure the content, it will give a good idea. I will be discussing on how to prepare these in the laboratories. Just pH and EC measurements. I told you 1:2 is the ratio. Preparation of saturation paste extract. Saturation percentage of soil is directly related to plant available moisture condition, and where the salt in milliequivalent per liter is equal to the EC in millimoles or decisimon per meter into the 10. Means it gives the approximate idea how much salt is present, especially in milliequivalent per liter. And if percentage of salt in solution, if we see in the solution, it is multiplied with the 0.064 to get the percentage of soil in the solution. Calcium and magnesium, these are the dominating ion in the saline condition. In the saline soils, where the milliequivalent of EDTA, we are titrating it with the EDTA. The whole method we cannot describe in the online platform, but all the manuals contains the information. The basic thing is that calcium is determined by EDTA method using muroxide or ammonium perporate as an indicator, and that this is a titration process. You have to very accurately check the change in the color. And estimating the magnesium by the difference of calcium plus magnesium determined in the laboratory, and the calcium can be subtracted from the total calcium plus magnesium. You get the idea about the magnesium, and milliequivalent per liter, it will give the results, and that can be converted to ppm or any other units required for the assessment. Determination of sodium and potassium by the use of flame photometer, where different filters are there, it can be used for determining. So in many of the countries, different ratios of soil water is being adopted. Sometimes in literature we see 1:1 is being adopted, and 1:5 in Australia is being adopted. So we have to mention, if we are determining pH and reporting it somewhere, there is need to mention the soil water suspension ratio which you have adopted in your work to get the clear idea about the pH of the soil. Stirring and settlement. During the laboratory method, stirring is required to solubilize the soluble ions present on the soil surface, and allowed to settle it or not, it will depend on the texture of the soil, how much time it requires to settle. Means position of the electrode in the supernatant as well as in the sediment. You have to be clear. The electrode should be dipped properly to get the good result. For the during laboratory determination, certain glassware and as well as buffers are required apart from the instrument on which the potentiometric method of for determining the pH. So this is the methodology in the pictorial. You can see the way the soil properly add to the take a beaker, especially in the it is written at 250 ml, but normally we take it of the beaker of the capacity 50 ml is sufficient, and for weighing the 20 gram soil, adding 40 ml of water, and then using the pH by standardizing the pH meter for 4.27 and 9.2 pH, and then you can take the reading of the pH of the soil. There are other quick test methods, especially the means we can get the strips available for pH testing, but it is not accurate. It just gives the idea how much is the basicity or alkalinity or neutrality of the soil. There are indicators, solution also. They also gives the idea on the basis of change in color. From red shows the strong acid, while the purple or blue shows the salinity or sodicity especially. As the pH, as you must be knowing, there are several chemical indicators which are based on the color, and that changes with at a particular pH range. Because this is a very important when you are reporting for soil health. If the soil is saline or sodic, then it becomes more important. Electrical conductivity, as I told you, it is the 1 centimeter cross sectional area where the electrical resistance is or conductivity can be determined. And in case of soil, you have to prepare the soil water suspension, and then movement of ions can be assessed by the use of electrical conductivity meter, which is available in laboratories, most of the laboratories. And the procedure is the same as preparing the for pH. You have to allow it to settle for say few hours, sometimes overnight also, so that the suspension can be settled, and you can get the clear supernatant without any interference of soil particles, and it can be reported in terms of decisiemens per meter. And if the soil is having more than 4 decisiemens per meter of electrical conductivity, these soils are basically saline in nature. During preparation of saturated paste for estimating pH S as well as ECE, water content is very important. If you are adding more water to the soil, then the pH as well as EC and other ions will get disturbed. You will see different values for different saturation. So proper saturation means there is a method you follow by taking substantial amount, say 200 grams of soil, and allow it to saturate it with distilled water and keep it for overnight, or depending upon the texture of the soil. And then the main aim is that all the ions should get solubilized into the water you have added, and then we use suction pump, vacuum pump to extract the water saturated into all the pores of the soil. And then in the extract, you will the collected extract will having the most of the ions dominated into the soil system, and this will give the correct idea about the salinity or alkalinity in the soil. So this is the basic things. Cation exchange capacity, the capacity of the soil to absorb or exchange the cations, that governs the soil health in terms of nutrient availability as well as ions. Apart from organic matter, high CC will be there if the clay content or organic matter is high, while sandy soils will have low cation exchange capacity. And if the CC is low, it also indicates the less organic carbon, poor structure, and this is all we will be discussing more on these aspects when there will be other presentations more concerned about the methodologies in the laboratory. Flame photometer is the important equipment. We can use it for estimating potassium as well as sodium. Sodium for the sodic soils, or for certain plants also in saline condition also we estimate the sodium. But in potassium, for it is an essential plant nutrients, and it is required for estimating in almost all the soil. This is also used for cation exchange capacity, where we are saturating the soil with the ammonium ion and sodium ion, and then replacing it with the ammonium, and then calculating it the total cations adsorbed and exchanged. Sodium adsorption ratio, it is just a calculation based on the sodium and calcium plus magnesium, and this can be easily determined in the laboratory by using flame photometer or by the method of titration. Gypsum requirement of the sodic soil, it is very important. What is the gypsum required? It is based on the exchangeable sodium percentage of the soil, which influences the pH of the soil, and the Schoonover 1952 method is being adopted, where we are adding calcium sulfate 2H2O, which is a gypsum, and gypsum having calcium dominance, which will replace the sodium on the exchange site, and this sodium will move out of the soil system in the form of sodium sulfate, and the calcium will form the calcium carbonate and other soluble forms. Although these methods are difficult in laboratory to estimate, so for gypsum requirement, we have developed a GypCal application system, where the soil pH and on the basis of the texture, we can determine the quantity of the gypsum required for reclamation of sodic soil. And this GypCal mobile application is available on Google Play Store. You can download it easily from the Google Play Store. GypCal, both in English as well as Hindi, it is available. It helps in estimating the sodicity of the soil, how much gypsum is required to reclaim, and how much productivity of these crops, these soils can be governed, and what estimated crop yield can be obtained from these soils if you simply by giving a input in the form of soil pH or say texture of the soil. You can download from the Google Play Store. It is available, and it will give the as output, you will get the gypsum requirement and the depth of water required for leaching the soil to flush out the salt from the soil system, and expected yield in quantity per quintal per hectare. And GypKit is the another testing kit for soil in the field itself, to get the idea of how much sodicity is there, how much gypsum is required for the soil to replace the sodium from the exchange site. Management aspect will be based on the assessment. When you have assessed your soil, then you get the idea how much sodicity, salinity is there, what is the soil health condition, and on that basis you will apply the management practices. Means if the saline soil is there, you can apply drainage system, especially with the good quality water, leaching out and flushing out the salts. In saline sodic condition, where you can add calcium in the form of gypsum or any other amendment available locally, especially in Bihar, we see pyrites are available. Leach with high quality water to remove the excess salts, and leach with high calcium irrigation water to enable exchange of sodium with calcium. Addition of gypsum, as I told you, in sodic soil is the important inorganic amendment that is being followed. Deep tillage and leaching with high quality water is, if possible, that can improve the soil health of this sodic soil especially, and allow for 10 days of 10 centimeter water stagnation in the field to allow flushing of the salt, especially the sodium sulfate, from the soil system. And once the reclamation is done, your soil will rebound for production, and addition of organic matter and organic materials will revitalize these soils. As you are aware that soil health is dependent upon the health of the soil, and all the plants as well as animal health is also dependent on soil. So we have to manage these soil for their health to maintain the human health. This is all from my side, giving about the concepts and practices, what can be adopted in, especially in the salt affected soils. And if any query from the participants, you are welcome to discuss. Thank you very much.
Thank you, Dr. Arora. You have discussed detail about the soil degradation, status of India and how salt-affected soil formed and how we can reclaim it, and what is the importance of healthy soil, and we have to use the proper balance for fertilization. So now it is a session for open for discussion. If anybody have any query, just unmute themselves and switch on their videos and ask the question, please.
Good afternoon, sir. Sir, myself, Dr. Indu Chopra, sir.
Okay.
Sir, my question is Dr. Sanjay Arora. Sir, जो हम saline soil का reclamation के लिए अगर हम calcium mix और अगर हम irrigation water डालते हैं, तो sir, how feasible is it, sir, अगर हम कहें on monetary basis to reclaim the soil, क्योंकि sir, is it possible to get it reclaimed economically so as we don't get, sir, we get benefits when we grow the crops on that soil after reclamation, sir?
Actually, saline soil के लिए कैल्शियम वाटर की इतनी फिजिबिलिटी नहीं आ पा रही इंडिया में खास तौर पे, बिकॉज saline soils do not means already have calcium and magnesium in the soluble forms, but good quality water means without these dominant ions. If we are applying, say, rainwater, collecting the rainwater and using it for flushing the salts to remove the salt, it will be beneficial, it will be cheap. But in saline sodic or in sodic condition, you have to add calcium, soluble calcium, maybe from gypsum or calcium dominating water. Calcium dominating water, actually in our country, we are not having this in ample amounts. So application of gypsum or organic amendments which we promote can be beneficial. But in saline conditions, there is no need of adding calcium dominating water, because it will aggravate the problem. It was I told you regarding calcium water in terms of saline sodic as well as sodic condition, where we want exchange of sodium with the soluble calcium.
Thank you, sir. One more thing, sir. जैसे हम कहा कि हम टिलेज करें, सर, जैसे अब क्रॉप रेजिड्यू की हम बर्निंग का भी इशू है, एंड सर क्रॉप रेजिड्यू जितना सर मैंने काम किया या देखा है, सर क्रॉप रेजिड्यूज जनरली एसिडिक इन नेचर, क्योंकि सर उसमें कार्बोक्सिलिक हाइड्रोक्सिलिक ग्रुप्स हैं सर उसमें. सर, इफ वी यूज क्रॉप रेजिड्यू along with microorganisms to, sir, मतलब सर हम salt affected soil में यूज करें, सर what are the possibilities to get the soil reclaimed? क्योंकि सर अगर हम कह रहे हैं कि saline sodic या sodic soils हैं सर, वहां पर क्रॉप तो जनरली नहीं ग्रो करती है, तो सर वो रेजिड्यू को वहां पर लाने का भी एक एडिशनल खर्चा होगा. बट इज इट फिजिबल सर कि अगर हम उससे रिक्लेम कर सके रेजिड्यू एंड सर हमारे जैसे फॉस्फोरस सॉल्युबलाइजिंग फंजाई हो, माइक्रो ऑर्गेनिजम्स हैं या और माइक्रो ऑर्गेनिजम्स, इज इट पॉसिबल टू?
अभी मैंने आपको बहुत ज्यादा अप्रोचेस बताई नहीं, पर उसमें वन ऑफ द बेस्ट अप्रोच, feasible approach, cheap approach, environmental eco-friendly approach is use of organic materials into the soil system, and crop residue is one of the important means waste we say, but it is one of the asset for the sodic soil. Because these soils are poor in organic matter content, and the poor organic matter content results in poor structure and texture as well as infiltration, physical deterioration of these soils is there because of the less organic matter content. If we are enhancing the organic matter by adding residues, and residue decomposition will result in organic acid production, as you told, then there are improvements in our research also. In our institute also, we have developed bioformulations, especially Hello CRD, crop residue decomposer. In IRI also there are decomposers, and Dr. Patra also said about the decomposers at Indian Institute of Soil Science, Bhopal. So these decomposers helps in faster decomposition of the residues, and residue incorporation earlier was means we were means seeing that this was causing immobilization of nutrients, and sometimes there will be high CN ratio and the soil will not perform, the crop will die. But with the application of organic means these residues with decomposing organisms will surely decompose at a stage where the soil health will be maintained. Not only soil health, but crop productivity can be sustained. But as you told that salt affected soil, from where we get the residues in sufficient quantities. Actually, 6.73 million hectares of salt affected soils are there in India. That doesn't mean that these are not productive or they are not producing at all. They are producing. The farmer is tilling the land, the farmer is using the land for crop production, but the yield is not optimum. The yield has reduced to say 40% or 50% of the optimum yield. So these are the virgin soil where we can target during the coming years to enhance the productivity to the optimum level by the interventions as you suggested, especially the residue management. If the chemical amendments like gypsum or good quality water are not available, then addition of organic materials. Also, microbial activity enhancement through different microbial formulation we have developed, especially the nitrogen fixers, phosphate solubilizers, and other VAM. These because the soils, especially the salt affected soils, have poor biological activity, and if biological activity can be improved, then certainly the plant growth can be sustained.
Okay, sir. Thank you so much, sir, for your very good presentation. It sir just bound us, and I couldn't go here or there. Just I was listening to you. Thank you so much.
Thank you. Thank you.
Good afternoon, sir.
Good afternoon.
Sir, Mahendra from Varanasi, Research Scholars. Thank you for your nice presentation, sir. I have two questions, sir. Firstly, what is the cheapest and easiest way to identify the nature of a soil in the regard of a farmers? Because we are the scientific community, we know each and every methods and procedures in the laboratory, but the farmers cannot use all these procedures and methods, sir, for to analyze their soil property. So my question is that, sir, how and what is the easiest way to know and to identify the nature of a soil, that is either acidic or basic or alkaline or sodic? How the farmers can know in the easy way?
Yes, yeah, I got your point. Dr. Kohli, you want to add something, or I should respond?
Dr. Kohli?
Yes.
Dr. Kohli?
Have you got?
Yeah.
Dr. Kohli, you got the question?
Yes. So he wants to say that if there is some problem in a soil, what is the way he can come to know about the solution or the problem as such? Is this the question, Dr. Mahendra?
Yeah. So my question is that how the farmers can know the conditions of the soil.
Yes.
That is, they are not able to understand the EC, they are not able to use the pH meter and all these things. We are scientific community members, so we can understand and we can analyze, but the farmers are unable to analyze all these procedures and equipment. So how they can know their actual conditions of their soil?
Yes. Okay. So as you see, there are many things, many indicators, many visual indicators through which farmers can come to know about the status of their soil. Okay?
Like, sir?
For example, if you talk of salinity, farmers themselves know that if the soil is visible at the top of their soil, on the soil surface, if the soil crust, if the salt crust is there, if a layer of salts is present, they can know. And otherwise also, if these symptoms are not so distinctive on their soils, the farmers at least know that there is some problem, there is some yield reduction, or they find that their yields are not appropriate. So they just have to contact an expert. Let me complete, Dr. Mahendra. I'll take your supplementaries after that. What I want to say is that they are at least able to understand that there is some problem in their soil. Then the right approach is that they should visit a soil testing laboratory. First of all, get appraised how to take a proper sample. If it is possible to get a expert visit their field, that is the best thing, nothing like that. But otherwise, they will, the soil testing people, the laboratory staff will guide you how to take a proper soil sample, and then on the basis of the soil test results, they can at least have an idea of the potential problem in their soil. Now,
Sir, is it feasible to do for all the farmers, sir?
It is feasible, yes. You see, if you do not, if a particular farmer does not have any problem, okay, if he is reaping bountiful yields and is not able to perceive any problem, then there is no issue. If he comes to know of a potential problem in his soil by way of either a yield reduction or some other problem, or maybe like even some of his relatives or friends or any acquaintances, they tell him that your soil might be having this problem. Maybe like they find that a particular crop is not growing in his field. And then the farmer doubts that there could be some problem. Then he can at least go and contact a qualified person, a soil testing laboratory, for further guidance. Now, as far as you're saying, understanding about pH and DC is concerned, okay, you see, even we did not understand it when we were born. When we realized, first of all, we realized that these are the terms. These are just some scientific terms, and they are measured through an equipment. And then the next step is that we understand what is their physical significance. So this physical significance, they can only understand upon subsequent interactions with the scientific community. So for instance, if they just want to understand what is pH, so the best way to make them understand, if probably you are in that kind of a profession, you can just make them understand this by using a litmus paper. Okay, what you do is that let the litmus paper change color by making it contact with either a soap or a few drops of lemon syrup or lime syrup. Okay, so you can create some acidic conditions and alkaline conditions, and then the farmers will realize. And then if you make that litmus paper in contact with a particular soil, he will realize, yes, this soil is acidic or alkaline or neutral. There are a large number of ways in which we can make farmers aware, but that is a gradual step. You see, if he does not know anything about that, probably that will take some time. But there are ways in which we can make them realize what it is, what we are talking about. If we are talking about carbon, we can just tell them that yes, this carbon, with addition of carbon or with increase in carbon, your soil will be more lively and will look black in color, darker in color, will be soft. And then you can give an example that if you probably have been using organic matter in any of your particular field, you will realize how good quality soil that it is. Okay?
Okay, sir. Okay. Thank you.
I will add something.
Yes.
Dr. Mahendra Kumar, actually,
Yes,
what we are seeing that during last 2 or 3 decades, farmers are means very much active, either by the state agencies or by the government schemes. They are getting their soil testing done, but in remote locations still there is issues regarding awareness of soil health or soil issues. But the what we are seeing, especially in 7 or 8 districts of Uttar Pradesh, which we are targeting, farmers get the idea about salinity or sodicity based on the vegetation it is supporting. In sodic soil, there is an indicator crop or an indicator vegetation. Say loony grass, we say, the salty grass. The grass itself indicates that there is presence of salt. This can only grow when there is dominance of particular salt. Sometimes water infiltration is just after rains, the water get deposited on the soil surface. There is stagnation. There is the texture is of very means clay, and you can easily tell that this soil is the infiltration is very poor, and on after rainfall the soil gets dry from the surface, but uh, in the next layer, say about 10 centimeter below, you will see a very damp soil is there. So whenever we can press with the foot, we will see that the on the surface it is dry, but the foot goes into the soil, indicating that there is dampness or waterlogging is there. So this indicates that there is uh, a textural problem which is developed due to sodicity. Also, if the nutrient deficiency, sometimes nutrient symptoms of certain, say in the belt of Unnao and Kanpur areas where the farmers are taking dominant crop as the mustard many times, and this mustard is a very exhaustive in terms of especially uh, uh, sulfur, and there will be deficiency of sulfur. There's the symptoms which matches with the nitrogen and zinc sometimes appear, and farmer can identify. But the basic idea can be easily seen by visual symptoms, by some of the indicators. But for proper analysis, for proper estimation, awareness among the farmers for going soil testing, which is available in every district, it will be required. But as a soil scientist or the means devoted towards the soil science or development of soil, if we are talking, then we should first promote, or otherwise our duty, we will fail in our duty to promote farmers for going up, for doing their means for provoking them to test their soil at least uh, once in a 4-year time, to get the proper idea from a reliable soil testing laboratory.
Thank you, sir. Thank you for a nice explanations, and I got your points. I will explain, and I will pass this message to farmers. Thank you, sir. Thank you.
Thank you. Thank you.
Anybody else?
Yeah, then there is one question in the chat box.
So my question.
Yuti, okay, Suman. Yes,
Okay.
you can continue. Suman, please put up your question.
Okay. Good afternoon, sir. My question for the Mr. Dr. Arora, sir. Sir, my question is very little, but I want to know about that. You mentioned that that is PHS, that we calculated from the saturated paste or saturated extract. Sir, I want to know that from you how we prepare the saturated paste and what is the ratio. And I also want to know from you that we use, that is the EC meter or the pH meter. We in general, that is we use 1:2.5 ratio. How can we use this pH meter or EC meter for the testing for the saturated paste or saturated extract?
Okay, the pH meter will be same. The pH meter is okay, no problem. You have to calibrate it with the same standards buffers you are using. But the methodology says that we want, because in 1:2 or 1:2.5, what we are doing is that stirring the soil with the water to allow the soluble ions to come into the soil solution.
Yes.
But sometimes most of the ions do not come in the soil solution, or if the concentration of salt or ions is high, it will take time to come because of the movement of ions in the very small equilibrium condition. But in saturation extract, what we are doing is saturating the soil to optimum water level to allow most of the ion to get solubilized and give them residing time. Means the saturation is allowed for say 12 hours or more sometimes, depending upon the texture, depending upon the climate, the temperature of the laboratory conditions. The whole soil, say about 200 gram of soil is taken in a plastic beaker, where we add water to the saturation level. Means saturation level means each and every particle get saturated with distilled water. It cannot be quantified uniformly for all the soils. It depends upon the quantity. The quantity of water will depend upon the texture of the soil. So, for say, if a clay loam soil is there, it will be approximately 200 gram. For 200 gram soil, it will be approximately 80 ml or 85 ml of water. And when you are adding that and keeping it overnight, what will happen? The ions will be the particles will be saturated. The ion will be desorbed from the soil surface and come to the soil solution, and immediately we are mixing it with the plastic rod or the glass rod, allowing the paste to form in such a condition where there will be no water flow from the soil, the paste.
Yes.
But the paste will glisten, means it will shine and flow freely, not much freely, means not in such a condition either it will remain solid or it will remain a pure liquid kind of condition where the flow of soil solution will be there, but it will be in the form of a paste where there will be shineness without any water drop coming out of that paste.
Okay.
So in that condition, you insert the electrode of the pH in the similar condition, not extracting it. You have just saturated it and allowed it. You have mixed the soil and you have prepared the paste, and now you are inserting the pH electrode into this paste, and you will get the pHs. For ECE extract, then you have to extract, because in pH meter there will be no problem related to hindrance by the particles of the clay or soil. But in EC, when you are determining EC, there will be transformation or movement of ions is required, and in that case, the soil particles, if present during the determination, will cause problem. So in that case, you have to extract it by using vacuum pump to extract the soil saturation paste. So water can be extracted from that, and in that water or the extract, you will determine the electrical conductivity.
Okay. So one more question, that if we take the same soil and the water, is there any difference between the pH or pHs or EC or ECE?
Same soil and?
If we take same soil, and is any difference occur in
yes,
the
yes,
values of
yes,
pHs?
Yes, you will get vast difference especially in sodic soil. If the pH of sodic soil 1:2 or 1:2.5, if we say it will be 9 pH, and in case of saturation paste it will be 8.5. Okay. So because what is actually the pH is the hydrogen ion activity, and hydrogen ion, when we are using saturation paste, all the methods or the classification of the USDA or Indian system for sodic soil or saline soil is based on the saturation extract. So determining pH 2 or pH 2.5 is not feasible to match with the category of the USDA or the Indian system of classification. So better to go for first you assess the soil by 1:2 or 1:2.5. If the pH is high, then determine the actual pH by using saturation extract.
Okay, okay. Thank you so much, sir, for your
Thank
nice
you. Thank
information.
Hello, sir.
Yes,
Hello.
yes.
Sir, I
Yes,
have one
please.
question. I have one question, sir. If salinity increases, it might be due to dryness or sir bringing area under irrigation, sir.
Mr. Prashant, first introduce yourself.
Sir, myself Prashant Rathod.
Yeah.
I am asking question regarding sir salinity increases is due to increasing area under or bringing area under irrigation or enhancing or due to dryness. Salinity.
Both ways. Yes, I got your point.
Yes.
In both cases, you are increasing salinity, because in dryland salinity, especially in Gujarat or in Rajasthan, where we are unable to flush out the salts from the soil. So in that case, dryland salinity, whenever the climate is dry, the salt will move up and it will remain there in the soil surface. In many of the areas where substantial amount of rainfall is there, the flushing, the salt will flush out from the soil. But in canal areas or where the water over irrigation is we are doing, whatever irrigation water we are using contains certain amount of salt dissolved into the soil water. And when we are over irrigating our fields with this water, the salt will remain. As I told you, plant will not prefer to take salt from the root. It will only take water. And when the water is being taken, the salt will remain in the soil. And say for first year, you have added 200 milliequivalent of salt into the soil. Next year, again, irrigation is done, you add 200. Then next 200. So if the salt accumulation will be there in the soil, because there is less rainfall, the flushing is not being properly done, so salt will remain in the soil system. And whenever you are irrigating, sometimes the salt will move to the lower layers, but when the drainage is there, it will come towards the surface, as there will be evaporation and evapotranspiration occurring regularly. So means both the condition favoring the development of salinity. For example, in Hanumangarh as well as other areas in Rajasthan where Indira Gandhi Canal was introduced, and in Jammu where Ravi Tavi Canal was introduced, over irrigation and seepage from the canal resulted in accumulation of salts in the soil. And when the accumulation over number of years is regular practice, then the salinity will be developed. So this is very severe problem, and it is expected that if we continue with this practice of over irrigating and of not lining the canals with proper lines, there will be regular seepage. And if the seepage as well as over irrigation with high soluble salts will result in increasing salt affected soil from 6.73 million hectare at present to about 11 million hectare by next 15 years.
Okay, thank you, sir. You have covered nicely all the topics. Thank you,
Thank you.
Sir, in rain-fed areas and
go ahead.
sodic soil, if we will add organic matter, will the sodicity decrease over 10 to 15 years?
Actually, in rain-fed areas you are talking about, na?
Yes, and sodic soil.
Yeah,
for long-term.
In rain-fed area, if the sodic soil is there, sodic soil cannot be improved without the presence of water. Water is drastically required because all the flushing, all the removal, all the organic matter decomposition required substantial moisture and water. So under rain-fed conditions, actually, it is very difficult to manage. But if the irrigation facility is there for reclamation, especially the chemical reclamation and organic matter decomposition, it will be sufficient. And once the organic matter is added to substantial amount in the surface soil, the flushed out salt sometimes doesn't cause much problem. But your question is very pertinent because in the areas where irrigation is difficulty, or say in dryland areas or in unirrigated areas, we say the sodicity once occurred can be improved by use of chemical amendments or organic amendments, but it reoccurs after few years because the salt doesn't leach out from the soil system. It moves towards the lower soil, but in the days to come or years to come, whenever the farmer keep the soil fallow for a particular time, the salt will come up on the soil surface, and again there will be chance of resodification. So the dual problem of temperature or moisture along with sodicity causes serious impacts. So, but if the farmer is regularly incorporating residues, applying manures, compost, which is a very not very economical, but it will be useful.
डिस्प्ले अब बड़ा है वाले
So will it be correct if I say that organic matter are not the first solution to sodicity? Only irrigation and chemical application are the first solution to sodicity.
The first solution is water. First solution is water, because in sodic soil, sodium may be on exchange side, but certain amount of sodium is also in soluble conditions and other ions are also there. Flushing is the major problem. So as one of our technologies says that before going for chemical amendment, you flush your soil with the good quality water to remove the excessive soluble salts. Then thereafter, addition of chemical can be useful. I just want to inquire, Jyoti Prakash Swain, from where do you belong? Means where you are working present, in which state?
Sir, my work was in Akola in dryland.
Okay, in dryland condition. And the texture is also, I think, a problem.
Yes.
In that condition, availability of gypsum these days is causing a problem. Availability of gypsum as well as the quality of the gypsum, whatever available in the market, is not up to the mark. So we are promoting to use proper drainage, proper flushing, and use of organic amendments like residues and all that, and use of bioformulations, which we have developed, microbial population, to be enhanced in the surface soil to improve aeration, to improve infiltration of soil, to improve some of the halophilic microbial formulations which we have developed, halo azo, halo PSB, halo zinc, halo mix. These are the halophilic microbial formulations that helps in improving the rhizospheric condition of the plant in these soils, where for a particular time the interference of salts can be reduced, because these organisms have the ability to either produce certain enzymes to reduce the stress, or they have the potential to use that sodium or the ions for their self-development, and in that process the soil rhizospheric engineering will be done, and for a particular time the crop growth can be enhanced. This is the possible solutions which we are expecting, apart from drainage or apart from organic amendments, microbial interventions can be beneficial.
Thank you, sir.
Good afternoon, sir. Myself, Patil Trupti. My
Yes.
question is, how do I know if my soil needs gypsum?
The basic, I told you in my presentation, the pH of the soil indicates the sodicity. If the sodicity is there, then only you have to apply gypsum. And how much quantity of gypsum is required for a particular soil can be assessed either by the estimating gypsum requirement methodology of Schoonover in your laboratory, or by the mobile application I told you. It is available on Google Play Store. You can download it, and in the input it will require what is the pH of your soil. You put the input, and the pH, on the basis of pH and texture, it will give the quantity of the gypsum required to reclaim that sodic soil.
Okay, thank you, sir.
Thank you.
Hello, sir.
Yes.
I am Sidaya Chinbi Devi. I am PhD scholar. So I would like to know that are the reclamations of acidic soil, saline soil, or sodic soil permanent or temporary, sir? And if not permanent, then after at how many intervals we need to reclaim it?
Very good question from a research scholar. I didn't expected such in-depth question from a research scholar. Actually, chemical reclamation are sometimes called as the semi-permanent approach, because semi-permanent means it can be permanent if regularly tilling is done, regularly addition of organic materials, proper irrigation, and followed by salt tolerant or crops that requires less amount of salts to be added to the soil by chemical fertilizers or that thing. In acidic condition also, the chemical amendments like liming or this can be done once, but there is a terms and condition for that. Once you are applying chemical amendment, it should be followed by regular cropping, regular addition of organic materials, judicious use of water as well as chemicals. Otherwise, keeping the soil fallow for a particular time, applying high quantities of water or any other amendments, or using chemicals in large amounts, in the process you will get resodification or re-acidification of the soil done in 4 to 5 years. It means
yes,
not on the methodology is the protocol for chemical amendment is a complete package. It is not only saying you apply gypsum and then forget it. No. If you apply gypsum, means like a in human also, if we have a problem of say fever or indigestion or something like that, the doctor will prescribe us a medicine. Along with medicine, it will be advised not to take this kind of food, not to drink this kind of things, not to eat heavily. Means there are certain other associated things that to be followed. Similarly, in case of chemical amendments, you have to follow the other part also as per the protocol. Go for less chemical requirement crops. Take, for in sodic condition, we say take paddy regularly to allow water to stagnate in the surface soil so that the salt doesn't reoccur to the surface soil. But if the farmer think that no, I will go for dryland crops, then within 2 years the salt will come back, because it has not gone out of the system. It has moved to the lower layers beyond the root zone, and without tilling or without following the complete package, the salt will again come to the system. So to follow complete package, you have to regularly manipulate, manage, and improve the soil surface to not allow the salt or the ions to come out to the surface soil to affect the crop. I
Yes,
think
sir. But
you get that.
sir, hello, sir.
Yes, yes.
Yes, sir. For amendment, we are using chemicals, but now in over the country, we are approaching to organic farming. And then but we need production also, optimum production. So in this time, how we can get it properly, sir?
Yes, yes. Actually, as per the organic farming or natural farming, you must be aware that gypsum is a
Yes.
naturally occurring mineral. It has been classified as a natural product, not as a chemical amendment. Means not as a synthetic chemical. It is not preferred to be produced in factories by mixing calcium carbonate or sulfuric acid to form calcium sulfate. It is developed by the agriculture grade mineral gypsum. Agriculture grade mineral gypsum is basically a natural product. Similarly, the pyrites are also the minerals developed in the nature. The mineral that marine gypsum, it is a source from the coastal areas where the salt is being manufactured with the high quantity of seawater, and once the seawater, the salt has been removed, the table salt which are produced from these manufacturers, the remaining calcium can be used for the as a organic material, or say natural material, which can be used in the natural farming.
Yes, sir. Yes, sir. Thank you, sir. Thank you so much, sir.
Then this Mr. Jyoti Prakash Soin had also asked, is there any unit or equation to quantify soil health?
No, it is not. Means for determining soil health, there are number of indicators. So one unit or there are several indices that that are being developed by certain institutes or say certain agencies. Like in our institute also, we have developed soil quality index based on soil health index based on soil solidity parameters. So whatever the problem or means features that are creating problem in agriculture in regarding the soil, you can use based on the dominancy of that problem as the indicator. So at present, certain sustainability index, sustainability yield index, there are certain indexes which can be used for assessing the soil health, not one single indicator.
Yeah, obviously there are many indices that are available, and you see in specific situations or in specific locations, different indices have been developed. So where you are working, if any index is available, you can go for that, or otherwise we also go for developing soil indices, soil quality indices.
And you can develop your index also, no problem. If you see in a particular area, if you are working and there is a problem or say something like that, you have identified it and you have tested it in laboratory. Most of the cases you find the similar results of that, and you see that this is the problem. Say for example, arsenic problem in a particular area. So if the arsenic is creating a problem, you can assign a rating or say marking based on the indicators, 5 or 6 indicators you identify, and then assess the soil on that basis. And if the problem is basically governed by that thing, you can develop the index of that.
Exactly. And you see, if you recall, I said in my presentation that the concept of soil health is not absolute, it is relative. it is relative to the situation in which you are working, the situation you are encountering. So soil health has to be quantified in that context only. So generally what we do is that we identify certain parameters that are affecting soil health, and then amongst them, we identify the ones that are affecting it to the most extent by using principal component analysis, and then we determine a particular quality index, which has got a few variables, because you see, there can be n number of variables that will be affecting the quality. But those variables which are more relevant to your ecology or to the situation under the question. Okay, so Mr. Swain, is it okay?
Sir, I have a question.
Just a minute.
Sir,
Yes, I think it will be the last question. If we can take
yes,
it.
sir.
There are, Dr. Arora, there are some questions in the chat box. I'll just read out them and then you can give a quick answer because they are similar. One of the questions is that can we apply azotobacter and PSB in saline soil for improving them? And then what is the effect of gypsum on the collapse potential?
Actually, Azotobacter, Azospirillum, phosphate solubilizer bacteria, these are the terms. They are having certain strains. If you have the halophilic strains or the salt loving strains isolated from the native saline or sodic soils, then they will surely be beneficial. As I was telling you in my discussion, that we have developed certain microbial formulations, and especially Azotobacter, Azospirillum, and PSB having the strains having tolerance of more than say high saline or high sodic condition. These are beneficial in remediation and bioremediation of these salt affected soil. It is possible and it is working. This is an alternative approach apart from gypsum, or after gypsum also we can adopt this approach. Okay, Samita.
One more last question. Yes.
Sir, so only
Yes.
last question, sir.
Yes.
Sir, we are assessing soil quality and we are also scoring it, sir. So what is the basic difference between, sir, linear scoring and non-linear scoring, sir? Will it hamper the soil quality index, sir, in some way?
Dr. Kohli. Dr. Kohli?
I'm unable to answer this, sir. Maybe
Okay.
this is more specific question. I do not know.
No. Actually, what she is saying that if we are giving a score to a particular soil parameter for means developing an index. As Dr. Kohli has already told that the soil health or soil quality is basically the relative property, means it will be in relation to certain other indicators. Marking or scoring based on the means the impact of that particular property on a particular soil you will be giving the highest rating. And this is dynamic in nature, means dynamic in the sense where you are working, you can develop your soil health indicators, say 5 or 6. So linear will be beneficial because linear equations, when developed, they give more R square values, and R square values based on the number of samples or number of population you have assessed.
Yes, sir. Okay, sir.
And
Thank you, sir.
you can go through our one of the publications in 2010. We have developed a relative soil quality index for rain-fed areas, especially for maize wheat system, and only 5 to 6 indicators, in not only the soil indicator but also the climatic variables which we have included in that, because in rain-fed areas climate, especially temperature as well as water rainfall are the important factors. So that can also be taken along with the soil parameters.
Yes, sir. Okay, sir. Thank you, sir. Thank you so much, sir.
Okay, thank you very much, Dr. Arora and Dr. Kohli. And it is very informative and very interactive session, first technical session. So with this, we have to break now, and again we will join at 2 o'clock. 2:15. Okay, 2:15 for the second technical session. So again, thank you.
All the participants, please join at 2:15 at the same link. This will be, means we will be putting a means hold on that, but you can join